Okay, so good evening, everybody, ladies and gentlemen. Thank you very much for attending our webinar this evening. My name is Ferry Harris. I will be your facilitator for today. And before we start, as always, some house rules. Please mute your microphone and then also stop sharing your video. This session is recorded. And then please make sure your name also appears exactly as the one that you registered through the form so that you can get the CP certificate afterwards. And then if you have a question, please raise your hand because you can ask directly the questions to the speaker. He wants to make sure that today's session is an interactive one. It will be slightly different than we used to as well because this time Dominic will do his presentation through a whiteboard. Before we go to Dominic, please take a note about our next big event, risk event. So basically, it's in the 16th of November 2023. So far, we already have 500 participants registered for this event. Make sure you are not forget about this, and all the information about the event, how to register, including how to register a group. For example, if you want to join the event together with your colleagues, you can see that on our website. Bef- Without further ado, I will hand over to our speaker today, Dominic. I know Dominic personally. We met each other in Germany a couple months ago, and actually, he's the founder of Hey Login, a password manager. And I personally use it, and I really like it. So I'm really curious as well what he will tell us about password manager and why 2FA is actually worthless when it comes to breaches. So, Dominic, the floor is yours.
Thanks, Ferry. It's great to be here and seeing so many people attend. So first, let me share my screen. Okay. You all see my screen, right, Ferry?
Yes.
Perfect. Okay. So as Ferry said, this will be pretty interactive. And for me, most of these things are well known, but for you, probably not. So if I'm too fast, please stop me. Just raise your hand and stop me if I'm too fast and ask your questions. And as Ferry said, the topic will be about password managers. I will go into a deep dive how the end-to-end encryption of password managers actually work and how the two-factor authentication in password managers work and why it's actually useless when there is a password manager breach, like happened with LastPass last year in December. So to get everyone on the same page, just let me shortly recap what's a password manager. So there is, in my opinion, there's two main features of a password manager. First is registration on a website. So if I want to create a new LinkedIn account, I go to LinkedIn, I enter my email address, and then I need to choose a password, right? And if I'm using a password manager, like 1Password in this example, 1Password generates a very secure long password for me that I can then just select from the dropdown and create my account. So the first thing a password manager does is creating passwords for me and storing these passwords. So I no longer need to remember passwords. Next time I log into a website, and on my example, LinkedIn, I go to linkedin.com/login, and then already the password manager pops up, typically in a dropdown. I just choose my username, and then everything is automatically filled out, and I can just press login, and I'm logged into LinkedIn. So there is a lot more features to password managers, but these are the main features that every password manager implements. And obviously, the main concern here is how are these generated passwords stored and retrieved? And how are these passwords I store in my password manager actually protected? So the typical way all these password managers like 1Password, LastPass, Dashlane implement their end-to-end encryption of all the generated passwords is by using another password. And this is called typically the master password. So it's a very long, complex, difficult to remember password, which is used to protect all these other passwords. It needs to be entered regularly. It kind of depends on the implementation and your settings. So you can assume that you typically need to enter this master password daily to access all the other passwords. This is basically like from a very meta perspective, how a password manager looks from the user experience side of point of view. And now I will actually switch to my whiteboard and explain a little bit more about how that works in detail, what you're probably all interested in. So this is actually my whiteboard. And as I said, we will do it interactively. So you can all just stop me. Ferry will probably call me out because I not
Yes,
always see
Dominik.
my laptop from here.
Dominik,
Yeah.
sorry, Dominik, if I may, is it possible to put your whiteboard in the center of the screen instead of the
Yes.
presentation?
Let me see.
Then we can all see the whiteboard in a big screen.
Oh yeah, I need to just stop sharing, right? So now it's working.
Yes, this is perfect. Thank you.
Perfect. Thanks. Okay. So how does this end-to-end encryption work? I will try to do it in a very easy way. So I mean, there's a lot of algorithms and complex data structures, synchronization stuff, but we will just look at the basics of the end-to-end encryption of these password managers. So what you first need to consider is the user, obviously. This is the guy or the woman sitting here, and this user choose a master password. Right, this is something that the user selects. This is not something that is generated because this is the 1Password that you still need to remember. That's also why 1Password is called 1Password, because there's still one last password, and LastPass is called LastPass because there's one last password, right? And this password is still something that the user needs to remember and enter regularly. So this password is typed into your laptop, for example. And then this master password is actually used to protect all your other passwords. And how does this work? So just to have some kind of depiction here, consider this like a vault, right? And in this vault, all your passwords are stored. And this vault is now encrypted using the master password. So like a naive approach would be just use the master password and encrypt the vault. But that's not very secure. What is actually done here is the master password is used to derive a symmetric encryption key. And this key derivation is a very crucial step. I will later explain why. In case of LastPass, so let's consider the example of LastPass. The algorithm that is used here is called PBKDF. Let's use a different. So the master password is an input to the PBKDF2 algorithm, and PBKDF2 actually stands for password-based key derivation function, and this is like the second version of it. So this is a standardized algorithm that is known for, I don't know, 15 years or something, to take a master password, so like something that humans generate, and then actually derive a key out of it. And this key is actually now used for the encryption. Of the vault. So this is now a very simplified overview of how the encryption in LastPass works. So this PBKDF2 algorithm, you can configure this algorithm with a number of iterations. And last year, this iteration here in LastPass, it was 100,100 iterations. And this PBKDF2 algorithm is actually slow by purpose. It takes time to derive a key out of a master password. And how slow this algorithm is defined by the iteration count. So you can increase that iteration count, and the PBKDF2 algorithm will take even more time to derive a key. So why is this done?
Sorry, question, Dominik. To your knowledge, are all password managers use the same algorithm?
No. Let me move that question to later, because I will show you with all the important password managers what they actually use. So there is different algorithms, there is newer ones, and there is recommendations from the OW ASP, for example. But this is just to have a very specific example. This is what LastPass uses. So to understand why this algorithm here is so important, this vault here is actually after the encryption is actually synchronized into the cloud, right? There's a lot of these vaults in the cloud of all the customers of LastPass, and all are individually encrypted with the keys derived by the master passwords of the individual users. So what happens if an attacker gains access to this cloud and steals a vault? So let's consider that this actually happened. Someone steals a vault out of that cloud, and then this attacker can, like just for the sake of example, also consider the attacker to have a laptop. And the attacker actually now wants to decrypt this vault here, which they have stolen from the cloud. So they need to do the same as the actual user. So again, there needs to be a master password. This master password is put into PBKDF2. A key is derived, and then this key is used to decrypt the stolen vault, right? So we have this algorithm, this is the key, this is an algorithm. The only difference here is that the attacker doesn't know the master password. So what the attacker actually does is doing this several times with different master passwords, like, I don't know, 1 million times, for example. just for the sake of example, for this example, until the attacker finds the right master password. And now we understand what the PBKDF2 algorithm actually does. It slows down the attacker, right? So if you just use the master password, derive a key, this would be pretty fast. So an attacker could try a lot of master passwords in a small amount of time until the right master password is guessed. But if you have this key derivation here, each try is slowed down by this key derivation. And now it actually makes sense that you have this configurable iteration count, because you need to actually increase these iterations over time, right? Because the hardware of attackers are getting better and better each year on the one side, so the attackers are getting faster. And on the other side, to protect against these brute force attacks, you need to increase the iteration count.
Sorry,
So,
Dominic, there's a question.
Sure.
There's a question from Peter. Which ones are public and which ones are private? I think he's talking about the key.
The key. So this is always a symmetric key, so it's private. This key is always derived from the master password, which is obviously something you shouldn't tell anyone. It's a private secret you know in your head. So this is always deterministically based on the master password. So it's a private key used to encrypt the vault symmetrically. And in the case of the attacker doesn't know the master password, so the attacker cannot deterministically derive a key. So the attacker needs to try a lot of different master passwords until the attacker guesses the correct one and then can decrypt the vault, right? If you are like a tech-savvy, security-cautious user, you probably have a long, complex master password. So that already helps a lot against these attacks. But still, it's very important to look at these key derivation function, because that's the one thing that slows down the offline brute force attacker here. Okay, so this is like really the basics on how like industry standard password managers do their end-to-end encryption, right? And before I talk about how other password managers implement these, just for the sake of the story, as I said last year in December, LastPass got breached. And breach in that case actually means one employee at LastPass had a vulnerability in a program on his computer. And due to that vulnerability, someone got access to his computer, and he was one of the employees who had access to the LastPass cloud. So over this computer, the attackers got access to the cloud, and they stole all the vaults from their customers. So all LastPass vaults are now no longer just available in the cloud, but also available on the attackers' computers. So there is the only thing that now stands between the attacker and the actual password stored in the vault, again, is the master password and the PBKDF2 function, which slows down this attack, this brute force attack of guessing the correct master password. Okay, so yeah, this is basically in general how this end-to-end encryption works, and it's very interesting to look deeper into this key derivation function, obviously, because how can we improve it that it protects even better against these attacks, right? Obviously, after the attack of LastPass, a lot of discussions are happening between security researchers and other password managers. So there is a lot of new decisions, new iteration counts. People are talking about that in my bubble all the time. So what you can do, you can draw like a graph, and I will start pretty simple. So this is the time complexity. Like if you study computer science and you had this theoretical computer science stuff, they always talking about time complexity, right? How long does an algorithm take to do something? And you can, let's say, PBKDF2, let's just put it here. PBKDF2 with, I just say 100,000 iterations, like for simplicity, it's like here.
Sorry, Dominic, there's a question
Yeah.
related to that. Does the attacker need to know how many iterations
Yes.
being used to generate the key to the brute
Yeah.
force, or they just okay? So they actually need to know.
Yeah, they need to know, and the old default in LastPass was 100,100 iterations. I mean, no user actually changed that, right? So all LastPass users had the same iteration count. There were even some really old LastPass users which had 5,000 iterations, and LastPass never updated these old LastPass users. But yeah, it's just, there were just two probable iterations counts, right? Just 5,000 of the old accounts or 100,100 iterations if you had a new LastPass account.
Okay. By the way, there's another question related to that from Johan. I think,
yeah.
Johan, you better ask the question directly if you don't mind to unmute yourself, sure. Johan.
Yes, I can. Am I auditable?
Yes.
Yeah, so the PBKDF2 function, as input, it uses, for example, the master key and a salt.
Yeah.
So the question is on the whiteboard, you only explained that the hacker needs to try to generate the master password to try to crack the vault, but the algorithm also uses the salt value. So my question is, what is your experience on breaking the vault if the two factors are unknown? Is it possible or not, because the hacker has no knowledge of the salt value used in the algorithm?
So you're right. I did a simplification there for the whiteboard. In case of how PBKDF2 is used in password managers and how this key duration protects against brute force attacks, the secret doesn't really matter because, let me explain. So let's just keep talking about the LastPass story. So these secrets needs to be stored somewhere, right? Sorry, the salts. The salts needs to be stored somewhere. And obviously these salts are stored on the server of LastPass. So if the server of LastPass is breached and you get all these encrypted vaults, you also get all the salts, right, that are associated to these vaults. In case of these salts, you cannot store them on the client side, interestingly, because then the salt would be something that the user also needs to know or store somewhere if you need to set up your password manager again on a new computer, right? So in case of password managers, the salts are just stored beside the vaults and they are stolen together with the vaults. So the salt doesn't really protect against the brute force of offline attacks here. Does it make sense?
Yes, it makes sense, but I hope that the salt is protected as well.
How?
I don't know.
That's why Johan said, "I hope."
I hope. Okay.
So there's a hope. There's a hope there.
Yes, I mean, because I mean, we are always talking about these data breaches. Like we assume that there was already a successful attack, right? And then we talk about what's the actual protection that is left after this attack. So I mean, LastPass probably had a lot of security software in place to protect the servers, but in the end, they were still hacked. So what is left is the only known, the only secret known to the user, which is the master password. Everything else we assume has already been breached in this scenario, right? I mean, yeah, this whole talk kind of assumes that there was already a breach like happened with LastPass, right? And if it can happen to LastPass, I mean, they're ISO 27001, SOC 2 certified. They had several audits. I assume it can happen to all the password managers. So we really need to talk about how to protect against these brute force attacks. Okay. So what's interesting here? Oh, let me put here who actually uses PBKDF2. So LastPass used PBKDF2. What the actual recommendation already was during the breach is 600,000 iterations. So this is the OWASP recommendation for PBKDF2. They say, please use 600,000 iterations. Actually, LastPass now switched, I think since May, they switched to these 600,000 iterations. Then there is a Bitwarden, for example. It's a well-known password manager. It's open source. They also used PBKDF2, but after the breach, so actually there's also an interesting story here. So there is an audit of Bitwarden that is now, I don't know, 2.5 years old, where in the audit that Bitwarden paid for, the security, the cryptography people already said, hey, you definitely need to change PBKDF2. That's not secure anymore. But they didn't change it. But after the breach of LastPass, obviously everyone was talking about it. So now Bitwarden changed their algorithm, and what they are now using is what is called Argon 2. So this is a different algorithm. It's pretty new. There was a competition to find the new key derivation algorithm, and this is the winner of that competition. And what's interesting here, we are currently talking about time complexity. So in reality, time complexity means for an attacker, I need a lot of CPUs, a lot of computing time, right? What is interesting with Argon 2, it does not just use a lot of computing time, it also needs a lot of RAM. So this is what theoretical computer scientists would call space complexity. So Argon 2 not just needs CPU time, but also a lot of RAM storage to actually compute the values. So yeah, you cannot just rent AWS servers to compute PBKDF2 if you're doing Argon 2. you also need to pay a lot more to get the required RAM to brute force these master password. So Bit1, they switched to Argon 2, and Dashlane, they were already using Argon 2 for some years. I think it was 2018. So pretty good move of Dashlane. Okay, so there is one competitor here that's missing, and that's because it's a little bit more difficult to explain. So 1Password. 1Password is actually my beloved competitor because they're doing a lot of things right. Interestingly, 1Password is down here. They were also using 100,000 iterations of PBKDF2, but so that's now the interesting thing I will talk about now about 1Password. So they not just use the master password, but they have actually a second secret that needs to be entered. So that's actually very similar to the question of salts. So in 1Password, there is a secret that is not stored on the server, but is also stored on the client side. Okay, but before I explain that more, are there any questions about this graph here? Obviously, there is a lot of more of these algorithms, but these are just the typical ones that I used in modern password managers.
No questions so far. I think we can continue.
Let me briefly switch to my slides because I wanted to show you something. So 1Password. So 1Password, they obviously also have a master password, but they also have something that they call the secret key. And I mean, the big downside of this secret key can be seen here. If you have no device left where 1Password is is installed, so let's say your laptop got stolen and your phone broke, so and you need to set up 1Password again on a completely new device. You don't just need the master password, you also need the secret key, because it's the second secret that is used for the end-to-end encryption. And to ease the setup procedure, 1Password released something what they call the 1Password emergency kit, which you can print out initially after the first decryption of your vault, and then you can just write down your master password and put it in your drawer or cabinet. So the next time you install 1Password somewhere, you need this emergency kit. So let's switch back.
Sorry, in that effect, so are you saying that 1Password still using 100,000 iteration instead of 600,000? Right.
I'm not sure if they changed it. I need to check it, but it actually doesn't really matter, because due to the secret key, they have a second thing that needs to be like retrieved from the attacker end, which is not available in the cloud.
Thank you.
Yeah, but yeah, to be honest, I haven't checked recently if 1Password has increased their iteration count. But yeah, it's like a usability security trade-off here, right? And 1Password choose security over usability because they have this additional secret key. So if you remember our initial image, master password. I just call it key derivation here. There's the key. Oh, this should be around. And then okay, this is the initial image. So what one password does is you don't just need the master password, you need the second thing here, which they call the secret key. And this is obviously also true for the attacker. If the attacker steals this vault, the attacker also needs the secret key, which is not available online. Okay, so that was like a deep dive, let's say, into the basics of end-to-end encryption in password managers. But the main question is still unanswered, right? So what about two-factor authentication? So again, you need to understand one of the crucial features of a password manager is to synchronize these vaults over all devices. So all modern password managers are synchronizing these vaults over the cloud. Right. So let's just, for a moment, consider this is the specific vault of this specific user in the cloud. There are obviously more here, but we are just looking at this one specific user in this example. So how is two-factor authentication implemented in 1Password --lane LastPass? We need some kind of second factor here that protects the vault, right? So what all these password managers are doing is two-factor authentication. This could be TOTP. This could be web authentication. This could be some kind of security token, like a YubiKey. All these kind of methods are implemented as a two-factor authentication mechanism, and these are used to protect the access to the cloud. So it's not even important here to dive into all these different methods, because these are just methods to protect the access to the cloud. They're actually not part of the authentication process, the encryption process. So, sorry, in case of a breach, again, where an attacker, in case of LastPass, compromised one LastPass employee and got access to the cloud, all these individual two-factor authentication mechanisms, all the individual users have set up, they are useless, right? Because I just compromised one employee of that company to get access here and steal all the vaults. So that's why I'm saying in a traditional industry standard password manager, two-factor authentication is useless in the case of a data breach, right? I mean, I know it's a little bit provocative. Obviously, two-factor authentication is not completely useless, but it's useless if you assume a data breach of that cloud already happened, right? Okay. Any questions here?
I think everybody's still thinking about like, is two-factor authentication really useless?
Yeah, I know it's provocative, but yeah, in the case of an existing data breach of the cloud, it's not protecting against the brute force attack of these attackers here.
Okay, so in this case, the thesis, let's call it like that, the thesis that two-factor authentication is useless is only in the case of the faults already breached. Is that correct?
Yeah.
So
Yeah,
if
correct, yeah.
in another case, let's say if the fault itself is not yet breached, then it is still useful. So to say.
Yeah, to a certain degree. But it's much, much, much more important that the employees of the password manager are extremely good protected.
Okay,
Because,
got it.
right, I mean, if you have over 2 million, or I don't know how many, 5 million users, if one of the LastPass employees is insecure, all these other two-factor authentication mechanisms are useless. So yeah, it's really important that these organizations are very, very strict in the security of their employees to protect against the data breach. But then again, password managers should still be secure even if the data breach happened. So that's what I'm talking about.
Clear.
Okay. Okay. That was basically the main answer of my presentation. So now I'm going to present, like, just from the basic overview, what could be an alternative way to design a password manager. So why do we even need to use a master password in 2023? I mean, every user today has a smartphone in their pockets, and these smartphones already have a security chip. Or why can't we use security tokens like YubiKeys directly for the end-to-end encryption? Why isn't this done yet? That's the question we were asking ourselves. So just from a basic overview, what you could do if you just think about it, if you have a security token or smartphone here that has a security chip, you could directly generate a key inside that security chip. So what is previously derived using a key derivation function from the master password could directly be generated inside that security chip. Okay, it's pretty small, sorry. So we have a key here that is generated, and then we don't need any key derivation function. We can directly use this perfect key to encrypt the vault, right? So in this example, the vault is encrypted using the key inside the security chip, and the vault is stored on the smartphone. So this vault again is synchronized in the cloud. And obviously also made available to laptops and other devices. Oops. So if you naively think about it, it makes sense to do it this way. What is left as an open challenge is how to decrypt the vault on the computer, because the key is here. So what you can do is you can do a communication channel between the smartphone and the laptop's browser, establish that in an end-to-end encrypted way, and then temporarily issue decryption keys from that security chip on the phone to the browser. That's pretty complex, but it works. So it's actually possible to build a password manager without any master password at all. If you master all these challenges, these technical challenges, there is still the problem of recovery. And that's pretty difficult. So in case of a master password, you can write it down, you can remember it. You will probably not lose it, like at least in typical case. But you can easily lose your smartphone, right? It can easily be broken or stolen. So there needs to be a way to switch over to other devices. So that's like the very difficult magic here that needs to be implemented. I don't want to dive too much into the technical details here, because that's like a whole nother topic. But that's the basic idea here, how we can build a different password manager. So, sorry that I'm coughing a little bit today. Let me get back and get back to my slides. So just like a small glimpse on how this looks. I mean, obviously we implemented this in HeyLogin. I mean, there's still some challenges left, but it basically boils down to a different user experience, because instead of entering a master password, you confirm on your phone, or you can use your YubiKey and confirm using your YubiKey. And that brings a different user experience, which you can see here. So again, if you like to log into LinkedIn, instead of entering username password, we detect these login forms and we go one step further here in the user experience and replace these login forms with HeyLogin. So you just click on your name, get a notification on your phone. So we wake up your phone, establishes end-to-end encrypted communication channel. You confirm, and this is the step that is typically the master password, but in our case, it's the unlocking of the security chip, which temporarily issues a key to the browser, which can then be used to decrypt the vault. So then you're logged in. So this is a different user experience. We try to improve the experience of password managers on different fronts. So this algorithm of detecting these login forms works on most websites. There is no integration necessary. And we are constantly adding support for different devices, right? I mean, we started with smartphones with iOS and Android, use the security chip inside that smartphone. Then we started supporting smartwatches to unlock the smartphone, which is pretty funny to use. Then we started supporting security chips inside inside your laptop. This is also supported by a lot of industry standard password managers, but in our case, it's not just two-factor authentication, it's really part of the end-to-end encryption. And
by the way, sorry, Dominik.
Yeah.
So I guess that's also related to the question from Johan. So why do you store the key on a smartphone and not in the TPM on the computer? So that's the one that you presented here, right?
Yeah. So yeah, it's possible. We also support that. But yeah, everyone has a smartphone, but not everyone has a modern computer which we can use to generate the key.
So then then the next question from Peter, which is very good in my opinion. But then if we are, okay, one user may rely on smartphone and then another user will use their laptop, another user will use their security key. Can it be somewhere that or somehow that we have a device independent way of authenticating in the future? Because again, right, everybody will have its own preference, so to say.
Yeah, that's true. I mean, the most portable device here is the security key, because you can just take it with you. You can have a pin on it as the second factor. You can just plug it into any computer over USB and then decrypt your vault. And it's also the most secure device here, because it's really just doing the just communicating with the security chip. There's no difficult sandboxing and vulnerabilities like on smartphones. So if you are in a critical infrastructure environment, we recommend security keys, obviously, due to their portability and security. But yeah, we also have a lot of like agencies as customers, like marketing agencies, social media agencies, and they obviously already all have a smartphone, so they use a smartphone. Yeah.
Okay, clear.
Okay, so yeah, that's basically what we support, and we are, as I said, always iterating on how to do it better and easier, make it more portable and more supported. So yeah, just that's basically the presentation. I mean, we can talk more about details, but just shortly about us. I'm Dominik. I'm the CEO. Vincent is my co-founder and CDO. We are a startup funded by Mozilla Ventures and some German business angels. So we are not like the most capitalist startup. There's not Sequoia VC or something at us. Mozilla Ventures only invests in companies that adhere to the Mozilla Manifesto, and we are pretty big fans of that. So yeah, that's my presentation. If you want to try out HeyLogin, which brings you the different experience, go to heylogin.com. If you're asking me what's like the best password manager of all the alternatives to HeyLogin, I always recommend 1Password as the first one, because they are really good at implementing a very good security architecture, have an open white paper, a lot of audits. If you're pretty tech savvy, you might also use Bitwarden, but yeah, if you are hosting it on your own, you should update it regularly and do audits on your own. So yeah, that's it.
Clear. We have one question from Jeroen. He has a very specific question on Argon algorithm, Argon 2. So if it is designed to use a lot of memory, is it still usable on less powerful devices? Or is the memory used server side? Because then, if that's the case, then it is going to be a very expensive protocol for any password manager provider.
Yeah. In case of password managers, I mean, these key derivation functions can also be used. Can also be used by websites for password hashing, but in case of password managers, the key derivation is always done on the client side. So yes, you're right. The client, so for example, the smartphone app of Dashlane needs to do Argon 2. So yeah, that can take some time, and it's always like a security usability trade-off you're doing here. You want, again, Argon 2 can also be configured, not just by one parameter like PBKDF2. There are several parameters for Argon 2. And you can define how much memory it needs. Yeah, and I think you should stay below, like, I don't know, 2 seconds for the user to not get annoying until the vault is decrypted. So yeah.
All right, cool. Maybe one last question from me. Apart from the technical discussion we have today, with all the the cases that is happening, and then the LastPass, the famous LastPass stories that you just described. Let's say we talk to normal users. How do you convince them to use password manager in 2023 if they haven't do so? Because all that's what happening right now, just to increase people's adamant not to use it at all.
You mean people who heard from the LastPass incident are now afraid? Is that the kind of users you're talking about?
That's one, and also the second one, of course, like before they never use a password manager, and then when they saw that news, like, okay, see, that's my point. So I don't want to even start one.
I mean, even LastPass is still secure if the master password is complex enough. But yeah, it's a very difficult customer you're talking about. So I mean, these are kind of tech savvy people because they heard of the LastPass incident. And they probably use, I don't know, KeePass, or they have their own algorithm in their head how they generate passwords. And I find it really difficult to convince these people, so we don't try.
Okay.
So our ideal customer is actually companies that switched into the cloud recently, like, I don't know, in the last 3 to 5 years, and are now overwhelmed with all these passwords, and they kind of lost control over it. And they are searching for a solution that works for their non-tech employees. And all these other password managers have the master password, which is not just a security problem, it's also a usability problem. It's an adoption problem. People don't like to type these master passwords every day. So we're kind of solving a second problem with A-Login. We are making password managers more usable for the non-tech people.
All right, clear. So one last, very last question before we close the session. Unfortunately, there is a unknown users. So for it says, for me, it is not clear why the two-factor authentication is useless if the hacker is on the server. Yeah. Is it because the hacker already passed the second security layer?
So what the attacker did in the LastPass case is they compromised one LastPass employee. This LastPass employee probably also had some kind of multi-factor authentication. But they used a vulnerability on the computer of that LastPass employee to work around that, right? So they kind of worked around a multi-factor authentication of one employee and then got access to the cloud and stole all the vaults. But all these other two-factor authentication methods that has been configured by the individual customers, they are now useless because they are just individual authentication methods against the LastPass cloud. But the attacker has already compromised the cloud, so he already got over that authentication, and it needs to be compromised by over just one LastPass employee. Does it make sense?
Yeah, it does to me, but I don't know. Let me check. Peter,
Yeah.
is the answer okay?
Yes,
For
it's
your-
clear to me. Thanks.
Awesome.
All right, cool. All right, then. For that, we close the session for tonight. Once again, ladies and gentlemen, thank you very much for attending the webinar. Thank you, Dominik, for spending your time with ISACA members in the Netherlands and also Norea. For everybody else, I'll see you again in the next event. And once again, don't forget to register your attendance in the risk event in November 16th, 2023. Until next time, my name is Ferry. Thank you very much and good evening, everybody. Bye now.